Hi everyone. So we are back for another 10 hours live stream challenge. So today I'll be solving some more crisp lead code questions or interview bit questions which will help us in cracking any interviews or moving further in our future. Okay. So let's do it. So last time we solved many of the questions from most of the topics. So this time I'll try to solve few more questions and let's see from few more topics. Maybe I'll try to solve today few specific top selecting specific topics, and then we'll jump to lead code questions based on some specific company, and then tomorrow I think we'll try most of the time with the lead code questions. So something like that we are thinking of. So today we have a special friend with us, which is Utkrisht. So he's also joined here. So I will show. Okay, so we have. I think everything is set up and we are good to go. I can show you that we have Utkrisht here. He's solving few questions. Hey, hi Utkrisht. Are you ready for the challenge? Let's do it. So I'll be in the meantime. I'll be showing you also on the stream. So we both can try and solve the question. Okay, let's do it. All the best. Let's try with some binary search question, starting with one or two maybe binary search question, and then we can jump to some other questions also. So last time we solved search for a range, median of array, rotated sorted array search. Let's try with this question. This is a good question. Okay, so let's try this question. This question says, given an array of integers of size n and an integer b, array A is rotated at some pivot unknown to be bare to you beforehand. Okay, that is 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2. You are given a target value b to search. If found in the array, return its index, otherwise return -1. You may assume no duplicate exists in the array. Note, array A was sorted in non-decreasing before rotation. So in this question, what this question is exactly saying is we are given an array which was earlier a sorted array. Suppose 1, 2, 3, 4, 5, 6 and 7. Now they selected a pivot point. Suppose this is one of my pivot point. So at this point what we are doing, we are rotating this array. We are moving this uh, so we are moving this and we are moving this half, sorting it some other. So the actual array will become something like this: 5, 6, 7, and then 1, 2, 3, 4. So this is actually the rotated sorted array, which is at a single pivot point we are rotating this array. Now we are given an element, suppose uh, maybe 3, 3, let's take 3. Now we need to search this for 3 value in our rotated sorted array. Now we can think of something like directly iterate over the array and then pick the value. So that will be one of the possible answer. That will give me a time complexity of O of n. Maybe the space complexity will only be O of 1 because we are not consuming any further space than the space that is already present over there. So the time complexity will be O of n. What will we do in this case? We need to solve this question in O of log n. Means what the actual binary search does, we need to apply the same logic over here also. How? That is the main question over here. Okay, so let's see how we can solve this question. Now as this is an example, let's try and solve this, figure it out how we can approach to this question. So we have this question 5, 6, 7, 1, 2, 3, 4. So 5, 6, 7 will have a graph something like this. Maybe this is 5, this is 6 and this is 7. It is a continuous graph which is growing. Now there is a second half also which is also a growing half, but this is disconnected from the previous half. So we can see that if we draw something like this 1, 2, 3, 4. Maybe let's take a white black screen. Not better. So they are not connected. From this point they are disconnected. This is a disconnection point and this is also disconnected. They are not connected. So 1, 2, 3, 4 is going something like this. 5, 6, 7 is going something like this. Now we need to apply a binary search on this rotated sorted array. How can we do that? So in this case we'll apply the same logic as we were doing in binary search, but there will be some small trick over here. So the trick will be we need to figure it out the mid value. Whatever we used to find the mid value, we used to find the mid value with r plus l by 2. So I would suggest there will be a prerequisite of learning binary search. If you already know binary search, then I might suppose I can guess that this mid you must be understanding what this mid will be doing. So suppose this is a mid. Now my left will be 0 at position 0. Now my right will be at the position of last value. This is my left at 0. My right is 1, 2, 3, 4, 5, 6. 6 index. So right is at 6. So we can find the mid as 0 plus 6 by 2. That will be 3. So we know that 3 index, which is 0, 1, 2, 3, 4, 5, 6. So we are at one position. This is the position where my midpoint will lie. Correct? Now we need to check this midpoint is lying in which half. Whether it is lying in a contiguous half of this 5, 6, 7 or in a contiguous half of this 1, 2, 3, 4. This is the thing which we need to check and which is the crux of this question. If we figure it out that in which half it is lying, then it's already solved. We are good to go. So we need to check in which half it is lying. So how to do that? First let's do with mid and left. We know my left position, my left pointer is currently at 0th index. Correct? My right pointer is currently at the last index, which is 6th index. Correct? Now we need to see my current value. Now imagine if we have a value 1, 2, 3, 4 or any value, and if we have a midpoint over here, this is a normal binary search that we are applying. What we will check? We'll check with my left. My left will always be lesser than my right, my midpoint. Correct? My left will always be lesser than, or even it might be possible that it will be equal to my midpoint, but it will never be greater than my midpoint. That I can 100% guarantee you, because that's how the binary search approach works. Correct? So in this case we can see that this is a half where where we are lying. 1, 2, 3 is the half where we are lying, my left and mid. So here if we check, if we see my mid value is currently 1 and my left value is 5. Now we can say that from here that this half has been rotated. This is the half where it has been rotated, because if it had been not rotated, then the value at the left pointer, we are 100% sure that it should be lesser than the value at the mid pointer. Correct? So this is our rotated half. So we cannot find a value which is in the rotated half. We need to find the value which is in the contiguous increasing order half. So we can see that this is the half where my value is contiguous. 1, 2, 3, 4. This is the contiguous value half. So we can only search whether my value is lying within this range or not. If it is not lying in this range, then we can be sure that this will lie in this half range only. If it is not lying in this half, and if it is lying in this half, we'll move further in this half only. So how we can check that? We checked with my left pointer whether this value is 0 lesser than or not. We saw that this is not lesser than, so we are 100% sure that this half is the contiguous increasing half. So we'll check whether my mid value, which is currently we are picking 3 lies in this range or not, from 1 to 4. Yeah, it does lie in this range. So what we'll do, we'll pick left pointer and we'll keep it on the right. So we'll pick my left pointer and keep at the mid position. Now my right is also, and this now will select another mid. Maybe this time my mid came over here. Suppose my mid is here, and the second time. Now also it's the same thing, will check whether my left half is contiguous or not, my right half is contiguous or not. This time both are contiguous, so we can select in any half. Okay, so first we checked whether my left half is continuous or not. So the first thing we saw that this is the mid value, and we found the value. If we didn't find the value, then what we can do is we can check that whether it is contiguous or not. It is contiguous, and whether our value 3 is lying within this range or not. If it is lying within this range, we'll move my right pointer to this pointer. If it is not lying in this range, we'll move my left pointer again to the mid value. So this is how we are handling all these questions. So now we will be solving this question and see how everything is working. So we are given an array and we are given a value. Let's try and figure it out how the solution will approach. Okay, so we are given a value. Let's take it as nums. That will be much easier for me to write. I will take a left pointer, which is my low pointer. Low pointer will be at 0, and a right pointer will be at nums dot size minus 1. That is my last index. Now b is a value that we need to find. Now what's our binary search approach will be? While left is lesser than equals to right, low, we are having low is lesser than equals to high, HIGR. Let's take this as high. Now we'll find the mid value, int mid. So in order to remove the overflow, we will do this technique. We do left plus right plus left by 2. This will stop the overflow half. Now if the nums of mid is equals to b, we know that this is the value we need to return the mid. Now we'll check with the half, the logic that we used over here. Now if my low, we'll check with the left half, the value at the left half. So nums of low, if nums of low is lesser than or even equals to nums at mid, then we can say that this is the contiguous half, and we need to check my target value in this half, else the second half will be my contiguous half. So if this is my contiguous half, left is my contiguous half, we need to check whether the value lies within this range or not. So I need to check if my target my target is b. If b is even greater than or equals to my nums of low, and b is lesser than nums of mid, because we already checked equals to with mid, nums of mid. If this lies in this half, then what we can do is we can move our high pointer to mid, else we can move my low pointer to mid plus 1. Now if it is not lying in the left half, if it is lying in the right half, so what we can do in this case, if my b value is lesser than equals to nums of high and if my b value is greater than nums of mid, in this case it is lying in the second half, so we'll move my my low pointer to mid plus 1, else we'll move my high pointer to mid. Now if nothing works, means there is no value, we will return -1. So this might be one of the possible answer. Let's try and run this and see whether it is working, or do we need to do some optimization. Okay, sorry, this mid value is low plus high plus low all divided by 2. Anywhere else I did this wrong? No. So it compiled successfully. The time limit was exceeded, maybe because we are handling this high. Maybe we'll handle this with mid plus 1, no, high with mid minus 1, and high with mid minus 1. If we run this, see, this time it should not, at least time limit exceeded again. Why are we doing any uh, if nums of low is lesser than or equals to nums of mid, we know that this half is the contiguous half, correct? Now we are checking in this half if b is greater than or equals to nums of low, and then b is lesser than nums of mid, that means they are lying in this, the value is lying in this half, so we'll move my high pointer to mid minus 1, else my move my left pointer to mid plus 1. And if in the opposite case, if this value is not, so we are lying in this half. So if b is lesser than or equals to nums of high, and b is also greater than nums of mid, so we are lying in this half, so we'll move my left pointer to mid plus 1, and also my high pointer to, else if this is not the case, if the value is not lying in this half, we'll move my high pointer to mid minus 1. uh, okay. And if low is lesser than or equals to, okay, I'll put a lesser than value. Why it is showing time limit exceeded? Are we doing anything wrong here? Let's check. While low is lesser than high, low is lesser than or equals to high, low plus high plus low by 2. uh, I think this is the overflow part somewhere. Yeah, correct. This is how I think there is high minus low. I think it's high minus low, low plus. This is the correct. Sorry, for handling overflow case, I added plus sign, which should not be there. Perfect. So we successfully solved this question. Uh, it took a lot of time. No problem. So this was a good question of binary search approach. So a nice question. There are a few more questions uh, of binary search, which was a very crisp question like Coco eating banana on lead code. So I think we can also use those questions also. This is also a good question, painter's partition problem. We'll try to solve these questions also. Driver की sheet. No bro, I'm only solving from interview, but solving from Striver. Striver is somewhere else, way beyond than me. So okay, we can we can maybe we'll come back to the binary search questions again sometime. We'll try to solve some few more questions. So which question should I go for? Maybe my hand is itching for two pointer, or maybe stack and queue. Stack and queue. Let's try for stack and queue, and then I'll go for two pointer, and then we'll go more down. So this is done. So last time we solved this sliding window maximum. If you guys don't haven't solved this question, I would must recommend to solve this question, because sliding window maximum is one of the uh, best question which you can do with a DQ, and this is really interesting to solve this question, or even to see the solution. So I would recommend to solve this question, and if you can, you can also see some my previous videos where I have solved this question, sliding window maximum. So this was a really nice question. Now let's try with clever stack. Maybe clever stack and then evaluate expressions, rainwater trapping. We have solved many a times this rainwater trapping question, but we'll try to solve it again. Maybe we can go with the largest rectangle in histogram. Okay, this is a hard question. Let's pick this question on lead code. It had some beautiful, should I say, UI, which showed something largest rectangle in histogram. Okay, I have already solved this. Let's not see the solution. Okay, so given an array of integers height representing the histograms bar height, where the width of the bar is 1, return the area of the largest rectangle in the histogram. So we need to find a largest rectangle in the histogram. So we need to somehow figure uh, how we can find the largest rectangle. So the given example, let's see an example. Example is given 2156723, and the figure is something like this: 2156723. The above is a histogram where width of each bar is 1. So we're given we have a fixed width of each bar which is 1. The largest rectangle is shown in the red area, which has an area of 10 units. So we can see largest rectangle that we can form here, the is 10. So maybe it's saying the rectangle can be a square also. So if we can see, we can also form an area of from here to here. If I can go, so the area will be 1 2 3 4 5 6. So the width is 1, height is 1, and the number of blocks is 6. So the area will be 6 only, which is not the optimal answer because the answer is 10. Now the second thing which I can go for is, maybe let's see what we can do. We can also go for this whole, maybe this will give me a better solution. So the height we can see over here is height is 2 and the width is 1, and the total number of blocks is 1 2 3 4 4. So 2 into 1, that is 2, 2 into 4, that will be 8, which is not even the correct optimal answer because we still have 10 as our answer. So we cannot go with this one, this approach also. We can do something else. Let's pick this half, maybe 5. The maximum that we can go is 5, and this is the sorry, my rectangle is not correct. So this is half. What we can see over here, the height is maximum we are going is 5. The width is always 1, so that is 5. But this is twice. 2 blocks are consuming this, so we can say times 2, which gives me 10. So this is the maximum that we can create from here. Correct. So we need to figure it out. Somehow we need to find a solution that can give me an optimal answer. So one approach we can do is we can go for a brute force approach and select a point. Suppose 2 is a point. We'll find all the bars whose height is 2 after this, or even greater than 2. So we can consider that in our answer with a height of 2. So if considering 2, so the next bar is only 1, so we cannot move any further. So 2 will be my maximum possible answer for this index, 0th index. Now picking up the next value, which is 1. So first index has a value of 1. Now we'll move the second pointer and check the stretch that it can go for. uh, Here even the stretch can also go to left and the stretch can also go to right. We need to know the minimum on the left. We need to track something which will give me a minimum on the left. In this brute force approach, every time we'll find an answer, we'll keep it in my solution. Okay, so the again I think in the brute force case, if we are picking the 0th index, the value is 2. So maximum number of blocks that we have iterated over here is currently only 1. So 2 into 1, that is 2, one of my possible answer. The next value is 1. So the minimum value will be my approach. So so the value minimum is 1. Now we have iterated over 2 blocks, so 1 into 2, that is 2. Again the minimum value is still 1. We iterated over 3 blocks, so 1 into 3, that is 3. 3 might be one of my possible answer. We iterated over 4 5 and 6, and then we pick the first index again, this value. We'll go backward also, we'll go forward also, we'll track our answers. It'll take a lot of time. I would say I'm not even approaching the brute force approach. It's not even valuable on thinking of that. So we can go with some optimized approach. In an optimized approach, what we can do is we need to know if there is a value. Suppose this 2 we are taking as a value, how much far it can go on the left and how much far it can go on the right, where the value is not decreasing from 2. So it can stretch on the left maximum till this block, which is 5. It cannot stretch further than this because the value which I can see is lesser than 2. We cannot stretch on the left. We can only stretch on, if we see on the right, we can stretch on the right till 3 because that's the maximum we can go, and that'll go beyond my array. So we can see that the number of blocks that we have is 1 2 3 4 4, and the maximum height is 2. So answer will be 8. The same thing, if we consider this as my block, the maximum stretch that we can go on the left is exactly this block, not more than this, and the maximum stretch that we can go on the right half is till this index 0 1 2, third index, correct? So the maximum height that we can have is 5 into 2, that is 10, which is one of my possible answers. So we need to figure it out how we can go to the left stretch, how we can go to the right stretch, and then to find our answer. So in that way, what we can do, we can keep a stack, something we can say a monotonous stack, which will keep track of the values which are greater than equal to the current value. So let's take this as an example. We have 2 1 5 6 2 and 3. Hello Saurabh Shikhar, how are you? So this is one of my array that we have. I will keep a stack. No bro, I didn't ignore, I asked you how are you. So let's take this stack. 0 hungry. Okay, you can have some food. Don't expect from me to give you something. Yeah, I have a hide and seek. So we'll talk after this solution. So 0 at index we have 2. We keep as our stack is empty. Now we see 1 index. We have a value at 1th index as 1. The value at 1th index is 1. So what we can see that there is a value which is 2, which is greater than this value. So we cannot stretch 1 on maximum to its left. If we are making a left 0 1 2 3 4 5, this is left max, we are tracking this on my left max, and the same thing we'll do with the right max. So the maximum stretch that it can go on left, the value is 0. Even it can approach to 0 because 2 is greater than 1. So we'll pop this 0, and we saw that the stack became empty. So for this, the left will be 0. For 1, Again the left will be 0 because the stack is empty. Now we'll push this 1 in our stack. Now we saw the another index, which is 5. Now 5 is greater than the stack top. Stack top's value is 1. 5 is greater. We cannot stretch this 5 on for any further to its left. So the maximum value that it can go is stack top plus 1, which is 2, the current index. Perfect. Now the next value that we can see is 6. So we'll also put this index in our value 2. We added this. Now the next value is 3. Next index is 3 and the value is 6. What we can do, we can check the stack top 2, which is actually a 5 value, which is lesser than 6. So can we stretch this 6 to its left? No, we cannot stretch this 6 also to its left because the value is lesser. So we'll put the stack top plus 1 in our this index, that is 3. It can only go to its maximum 3. So 3 is 3 index. I'll put it in my answer. Now we find out the index 4, which has a value of 2. Now this value 2 is smaller than the value at present at the index 3. So we can stretch this to its left because the value is greater. This value is greater. So we can pop this out. We can also stretch this further to 5. We can pop this index out also. But we cannot further stretch this because this value is lesser than 2. Stack top value is 1. One's index value has 1, which is lesser than 2. We cannot stretch this any further. So what we'll do, we'll make this stack top plus 1 value as in my I'll keep in my answer, which is 2, and also I'll store here as 2. Sorry, I will not keep here. I'll store it here and the index will go over here, 4. Now we have a value as 5, index 5. 5 has a value 3. Now we see at the stack top as an index of 4. 4 has a value of 2, which is lesser. We cannot stretch it any further to its left. We can only stretch when the current index value and the stack top's value is greater. Means if st dot top value is greater than value, so it's nums of st dot top is greater than even equals to the current value, which is I, nums of I. I'll make it nums of I. If this is the case, then only we are popping from the stack. We can see its value low. So the value at this will be stack top plus 1, 5. So we made a left max. The similar way we'll make a right max also. In this time the logic will be exactly same. The only thing that we need to take care is we'll have to iterate from rightwards, and we'll have to keep all the values on the right. So let's not consider this box. We have this box. Now the maximum it can stretch on the right is the largest value. So which is 5. Now 2 maximum it can stretch. See, the value at 3 is greater. So we can keep stretching it further. But beyond this we cannot. So the value we'll keep over here is also 5. Now we saw 6, but 6 we cannot stretch it any further because the value at 2 is lesser than 6. So we can only stretch it to which is this value minus 1, which is third index. It can only stretch till third index. 5 can be stretched till third index, so it can go till value 3. 1 can be stretched till total index, all the index. So 1 will be at 5. Now 2 can only be stretched on the right till 1. So 1 minus 1, that is 0. It cannot stretch any further. So this is my right max and this is my left max, what we created. After this we just have to find what is the left stretch and what is the right stretch and the current value. So we can see at 0 we can see the left stretch is 0. We cannot move any further on left, and the right max is also 0. We can, so the current value is 2 and left and right is giving me, means we'll do left max I, maybe let's make it right max I minus left max I plus 1. This will give me 2 into 1, that is maximum we can go is 2. We can keep this in our answer. Now for 1, the maximum it can stretch up to on right towards right is 5, and the maximum it can stretch towards left is 0. So the value currently is 1. So 1 into 5 minus 0 plus 1, so the total value is 6. You can see 1 2 3 4 5 6. So 1 into 6, the maximum it can give me 6. 6 is greater than 2. We'll keep this in my answer. Similarly, I'll go for this index. The maximum it can stretch on towards right is 3. The value is 5. Maximum it can stretch towards right is 3. The maximum it can stretch towards left is 2. Plus 1. 3 minus 2. 1. 1 plus 1, that is, so it should be in bracket. 1 plus 1, that is 2. 5 into 2, that is 10. So 10 is one of the possible answer. So this way we'll move further. So let's just try and code this out and see how we can solve this. Maybe we'll keep a vector of integer as left max. Left max will be size of my heights dot size. Currently maybe I'll keep this as 0. Vector int right max heights dot size. Let's also keep this value as 0. Okay, can't see there. Sir, why you use blackboard not whiteboard? I do have whiteboard also, but kind of I like blackboards. That's why. Hey, what I pasted. So this is my left half. This is my right half. Can't see chat is in front of that. Oh, okay. Maybe I'll just hide the chat for now. Chat box. That'll be more clearer. I'll keep a stack and st fill left max. I will call a function which will fill my left max. We'll have a left max. We'll go with heights, which will give me now again we'll have the same thing. Fill right max. We'll have right max. Okay, Saurav, after this I'll add that part also. I think the subscription part is working now. If anyone subscribes, it's showing. but the only one who has not subscribed yet. The person who has already subscribed and unsubscribing and then subscribing will not be shown. And after filling this fill left max and right max, what we'll do, we'll create our answer. And result will be 0. I is equals to starts. Yeah, you can try it. So what will be my result? Result will be kept maximum of result, or we have the heights of I multiplied by right max of I minus left max of I plus 1. So this will be my resultant, and lastly I'll return my result. Let's try and create this in our private method. This will return me nothing. Fill left max will have a left max is also, we have a vector int of ampersand GHT as heights. Now this will fill. Now we have a void fill right max, which will be exactly same. Just few things will be changed. Okay. Okay, now we'll create a stack and st. Maybe I'll remove my stack over here. We don't want this here. And I'll start filling my left max while I trade over the heights array. Heights dot size plus, and I'll check while my stack is not empty. While not my stack is not empty, and also okay, we are running out of time. We'll solve this question and then we can take a 10 minutes break. st.empty, the stack is not empty, and st.nums left heights of st.top, heights of st.top should be greater than or even equals to, should be greater than or even equals to current heights of I. If this is the case, I'll keep popping. Now if my stack becomes empty, if my stack is empty, then I'll put my left max of I as 0. If not, then I'll put in my left max of I st dot top plus 1. and I'll move further. So this will be my right max, and the same will go with my left max also. For this I'll start with my right side. Height dot size -1. I'll go till is greater than equals to 0 and minus I. Now while stack is not empty and heights of st dot top is greater than equals to heights of I, I'll do this will not be changed. If stack becomes empty, then I'll put here heights dot size -1, which will be my last index, else st dot top -1, which will fill my left max and right max, and after filling those left and right max we can form our result, which is already over here. Let's try and run this code and see whether okay, we have this as left max. Sorry, this will be my right max, also this will be my right max. Okay, there is something. Oh, I haven't pushed in my stack. Okay, st dot push I forgot. Okay, now it's perfectly fine. We are able to. Okay, now it's accepting. Let's just try and copy this solution on interview bit and see whether we are able to solve this or not. Fill right max, and we have a now make this as heights run. Okay, the code compiles and trivial cases passed. Submit it. Perfect. So today we also learned largest rectangle in histogram. A good stack question. I say there is some optimization also we can do over here. We can do it in one pass also, uh, which 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 we can optimize it. We'll see maybe in the second half something. So let's take a break for 10 minutes and we'll be back after 10 minutes. See ya. Just a second. Hello, I'm back. Let's let's try some more questions. Uh, Let me fix this pomos. I only did one session. Also, one more thing. Today is Saturday, and today we have a bi-weekly lead code contest at 8 p.m. So, who all are giving the contest today? I think I'll be giving the contest. My uh, from 8 to 9:30, but I won't be able to stream that because if I stream that and if my solution is copied, I don't know, it won't be copied because I don't write a good solution. But even still, if it is copied, then I'll get a ban on my account. Maybe let's see how well Utkrisht is doing. Let's just have a talk with him and see what he's doing. Hey, hi Utkrisht, how's your progress going? So, how much were you able to solve the questions? Let's see, are studying, doing some recursion and DFS and BFS questions. Is that right? Correct. Great. I'm also getting motivated from you for solving more BFS and DFS questions. Okay, that's better now. If we are motivating each other, that's a better way. Actually, I forgot to tell everyone that Krish will be solving questions on Java, and I'll be solving questions based on C++. That's why his all submissions are based on Java. Nice. So let's continue our work, and we'll see you after a short break after some time. All the best. Okay. Okay. So this was a good question that I solved. Now let's try and solve some more question. Hmm. Which question should I go for next? Maybe how can you push something inside laptop? Use hammer for pushing. Perfect answer. Okay. Krish, can you mute your mic? I think I'm able to hear your audio. Okay. Great. Okay, I think Utkrish's audio is not coming on the stream. Maybe I'll add that also. I'll do it. Add audio output from stream. Okay, I'll do this after a break. After in the break, let's try some more questions. So we solved one stack question. Maybe if I'll get some Q question. I was thinking of solving some Q question. Evaluate expression. Oh, it's an easy one. Nice. Let's try and solve this as fast as we can. I got stream planned in the evening. Nice. I'll be watching your stream. So the question is, an arithmetic expression is given by a string array A of size n. Evaluate the value of an arithmetic expression in reverse Polish notion. Sorry. What does that mean? Valid operations are plus, by, multiply and divide. Each string may be integer or an operator. Let's see if there is an example from where we can understand how we will be approaching this question. So the question is 2 1. Just a second. Oh, okay. Okay, so the question was saying we have to use some arithmetic operation, uh, 2 1 plus 3 multiply. So this will always be a perfect arithmetic expression, right? This might be one of the question that'll come in my mind. It might be possible that they will give some 2 3 multiply divide plus, but this is not a perfect arithmetic operation. Maybe we can see from here 2 1, we are given 2 and then 1, and we have a plus sign. Plus sign means what? We need to add these last two digits. We have to add. So my new will be 2 plus 1, that is 3. Now we have a 3 again, and we have a multiply symbol. So this multiply symbol means what? We need to multiply the last two values. So the last two values are 3 cross 3, which will be 9. So my output should be 9. Perfect. This is one of the perfect answers that we got. Cool. Let's take the another example. What we have to do is we have 4 13 and 5 in a contiguous way, 4 13 and 5, and then we have a divide symbol. So what does that divide means? Divide means 13 divided by 5. We need to pick the last two values, and then we need to make 13 divided by 5. This 13 divided by 5 will give me what? 2, maybe 2, because we have to return an integer only, integral only. So maybe that will be 2, and then we have to add it with 4. These two expression are boils down to 2, and then a plus symbol will, I'll take this expression and this expression and add this, which will give me an answer of 6. Oh, nice. It seems uh, this might be a easy solution for us. So what we can do over here is we can maybe pick 2 1 plus 3 and multiply. Let's do this. Solve this one first, and then we'll go with them. We'll keep a stack over here. We'll push to, if we are getting an integral value, we'll push directly. 2, we pushed it. We got an integral value again, we pushed it. Now we got a plus symbol. Now this plus means we need to add the two values that are on top of the stack. So we'll pop this one out 1. We'll pop this one out 2. We'll add those two. We'll find an answer. This answer, these are already popped. This answer will be pushed in my stack, which is 3. Perfect. Now we got another integral value, which is 3, so we'll push this 3 also in our stack. We got a multiplication symbol. What we will do again, we'll pop two values from the stack. So top two values will be popped, 3, and we'll use the multiplication operator in between them, and the answer will be 9, and I'll push this 9 in my stack again. Now my query is completed. So whatever the value we have on the top of the stack top, will be my answer. Correct. So this is my answer. The second example is also very similar. We'll push 4 in our stack, we'll push 13 in our stack, we'll push 5 in our stack. We got one division operator. Now this division operator, just we need to pop this 5, pop this 13. We got two values. Now what we need to do with these two values, how we need to operate? We need to operate with 13 divided by 5. We don't have to operate with greater, with the smaller value. No, we have to, this operate with second top stack top value divided by first stack top value. So 13 divided by 5, which will in return give me an integral value of 2. I'll push this 2 in my stack again. So we have 2 and 4 as in my stack. Right now we got a expression as plus symbol. Now we'll pop two values from top. 2 plus 4, we'll add them both, which will be 6, and I'll pop these two out and push 6 in my answer. So this way we can approach this question maybe. So let's try it out. We are given a vector of string ARR. Let's take this as ARR. Now what we need to do, we need to iterate through this ARR. I'll create a stack. Should I take an integer or should I take something else? Let's take integer only, because I have to return an integer value only. Stack ARR dot size. Now if my ARR of I is any of the operators, which is maybe plus, or ARR of, if ARR of I is this, then we need to do some operation. Else if ARR of I is equals to or minus, then we need to do some operation. Else if ARR of I is equals to a multiplication, then we need to do some operation. Else if ARR of I is equals to division, then we need to do some operation. Correct? If not, if not any of the symbol, then we know that it will be an integer. So what will we do? Operation your doctor. Yes bro, I'm a computer doctor. What we'll do, we'll push it in our stack. Stack dot push ARR of I minus 0. This will convert this into integer, and then we'll push in my stack. Now if we have a plus symbol, val1 will be st dot top, st dot pop. I'll pick two values from the stack, st dot pop, and I'll do the operation. What we'll do is we'll val1 plus val2, and now I'll push this in our stack again. st dot push, sorry, val3, maybe remove this. I'll directly push val1 plus val2 in my stack. If it is a negative minus symbol, so we do these operations again. We could have also have done this in a generic way maybe, but no problem. st dot push val2 minus val1. Now if it is a multiplication and if it is a divide, if it is a multiplication we need to multiply, and if it is a divide, val2 divided by val1, val1, val2 minus val1. Correct? Now at last what we need to do, we need to return st dot top, whatever value at the top of the stack will need to return. Let's try and run this and see if we are facing any error. Okay, we are. No match for operator equals to. Why is this so? Val1 st dot pop, val2 st dot arr of I is equals to plus. We'll take only character, right? Correct. Why it is throwing an error? Mm, 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 mm. What can we do? What can we do? This should not happen. It's not a character. Can I add a double quotes over here? Maybe that will help. Let's run. If I'll get an error on minus symbol, okay, it'll be a double quotes. No issues. Inside double quotes. It's actually a character, right? I don't know why it's taking it as a string, but it's fine enough. It's saying vector of string. Vector of string means what? Uh, we have a vector and a string. Maybe let's debug this. Let's stack dot push 1 and see out arr of 0. What it will print, I need to know. Comment this out. My function returned a value 2. Instead of 0, 1, 2. 2 is giving me it's correct. Why? Then why? It's not compared directly. No, no. I'm sorry. With y slash. I haven't added slash anywhere. Come on, bro. Why? Or we can use stoi stoi of ch, which will convert it into string to integer. That's why I hate interview bit. I don't know why logic is irrelevant of these things. Perfect. Nice. So this is mission. Okay, I just needed 2 minutes. I'll be back in 2 minutes. Sorry, I'm back. I got some call. Okay, I also paused. Yes, let's start it again. Okay, let's go. So we completed this evaluate expression. We knew the logic, but as I say, I'm not very much comfortable with interview with UI or editor right now. Or maybe in near future I will do. Okay, so there is one more question, which is first non-repeating character in a stream of characters. Uh, let's try and solve this question. This is a queue question. We have solved two stack questions. Let's solve one queue question and then we can jump to some another topic. Maybe two pointers or maybe something else. Now after solving few more questions of a specific topic, then we'll jump to lead code questions where we'll do some random questions. Solving some random questions. I was thinking of keeping all these things in a place so that I can add it in my description box. Maybe that will help you guys to solve more question. I'll create one note and here I'll copy questions and paste it here. Few more questions. After solving this question, I'll do it. Okay, so the question is given a string A denoting a stream of lowercase alphabets. You have to make new string B. I have to create a new string which is B. Now B is found such that we have to find first non-repeating characters each time a character is inserted to the stream and append it to the end of B. Okay, I didn't get it again. B is formed such that we have to find a first non-repeating character each time a character is inserted into the stream and append it at the end of B. Okay, if no non-repeating character is found, then append hash at the end of the B. Okay. So maybe let's just take the second example, uh, because we have a hash over here. I'll also handle my hash part. A B C. So it's saying that first non-repeating character, first window is A. Now we are taking AB. Now we are taking ABC. Still no character has repeated, right? First non-repeating character is A. First non-repeating character is A. Okay. Now we have A again. Now this time A has repeated. Now this time mm, we know that A has repeated, but B is the second non-repeating character. Correct? So in this case B will be returned. Okay. Now we have A B. Now B is also repeated. So we have a C as a first non-repeating character in this window. Now we have A B C. Now all the characters are repeated twice. So in this case we don't have any character left which has repeated uh, once or which has not repeated yet. So in this case we'll return a hash. Okay. Okay, so how can we approach this question? This is actually a good question. Maybe we'll try and figure out the solution for this together. Let's try. How can we do it? We know A is here. B, how to figure it out that A has already been occurred, B has already been occurred, C has already been occurred, or something like that. So we need to keep it in map. Okay, a map will help me track. Okay, A's occurrence is right now A. Now B also came. B also we pushed. Now B, number of times it occurred is once. Now C we also pushed. Now number of times C occurred is also 1. Now we got A again. Now suppose instead of this we had have B repeated again, then A, and then maybe C. I'll figure it out after this. Okay, just a second. Okay, so now then another character which came is B. Now we know that B has occurred twice, so B's occurrence is 2. Now we check if this has occurred twice or not. No, so this is the first character which has not occurred twice yet. Okay, so we'll still keep my answer in my answer A. Now comes a character A has occurred twice. Now we see we don't have to keep it in queue if it has also already occurred, so we should not keep it in queue. Now we see A has occurred twice. What we will do, will we saw that we need to return first non-repeating character. We checked the queue back. A has been repeated, so we'll pop this from back. Now we check B has already been repeated again, so we'll pop this B back again. C has not repeated yet, so our answer will be C, and will not push A again. Now we see also C. Now from back we'll check C, has it repeated more than once? Yes, so I'll pop this out. Now there is no character, so in this case I'll put a hash over here. Okay, so the intuition behind this, we need to keep a DQ for this and a hash map. Hash map will do what? Hash map will give me an intuition that whether uh, this has occurred earlier or not. Already occurred or not. Correct. And this DQ will give me the first non-repeating character. Great. Okay, let's try and try run a solution again. This ABC again. So we have A, B, C, A, B, C. So this is my question. Let's try run this. Let's try whiteboard. See, I got a whiteboard. So in DQ, what we will do is we have a DQ over here and we have a map over here. We pushed, uh, we'll see map has no occurrence of A. So we'll push this in our DQ. A has the first occurrence, and in this case also, whatever the DQ's back contains value, if this value has an occurrence of only once, then I'll keep it in my answer. So I'll create my answer. I'll keep A in my answer. Now I added B. B is added over here. Now B's occurrence is also 1. This is for the first time B has occurred. So I'll push it in my DQ also in front. And from back I'll check whether A has occurred more than once. Is it? No, A has not occurred more than once. So I'll keep A as my answer. Now we track C also. We add it in my map. C. We saw that C has occurred only once in my map. So I'll add this C in my DQ also. And from back again we check A has occurred more than once. No. So I'll keep my answer for A also. Now we go to the next A. Now this time A will be updated with 2, value 2. Now A has already been updated with a value of 2. I'll maybe I'll push this in my map. I'll push this in my queue A, but from back if I see A has already occurred twice, so what I will do, I'll remove this A. I'll also reduce the occurrence of A. Now B has occurred only once, so in this case now my answer will be B. Now we go B again. B's occurrence is twice updated in my map. Now from back I'll check B. How many occurrence do we have of B in my map? It's 2. It's more than 1. So that means this has been occurred again. I'll push this in my DQ also and I'll pop this out. I'll reduce the value as 1. Uh, do I have to reduce the value? And do I have to keep it in my DQ? That's one question that I don't think we have to keep it in my DQ also. Not even here, and neither we have to reduce the occurrences. We'll check. Right now what my thinking is, we don't have to do this. Now we popped this also. Now C has occurrence of 1, so I'll add C as my answer. Now the next character is C. C, the value increased from 1 to 2. Now we don't push it in my queue. We checked from back whether C has occurred or not. Its value is 2. I'll pop this one also. Now my DQ is empty, so I'll put a hash at the back. So my answer coming is AAABC hash. So what's the actual answer? AAABC hash. It's perfect. So I think we can go with this solution. Maybe if I'll get some error, because I have 1 or 2 doubt which may be handled. Okay. So this is a string, maybe I'll keep str or s for int I is equals to 0, I is less than str dot size plus plus I. I keep a deq, deque, deq of character, deq, and also I need to have a map. I'll keep an unordered map of character with its value m. What I'll do, f ham of str of I plus plus. Now we need to remove it from. Now if the first thing I need to check, if m of str of I is equals to 1, then I'll push it in my deq. Deq, what I'll push, str of I. Push, maybe not back, maybe push front. I'll be pushing it in my front. Now while not deq dot empty, deq is not empty, and also the value at the so I need to deq dot back, the character at the back has a value of greater than 1. M of deq dot back is greater than 1. So what I'll do, I'll pop that deq dot pop back. I'll pop back, right? Now if I'll check if my deq dot empty, if my deq is empty, I'll create an answer. I'll create a result. If deq is empty, then I'll result dot pushback, or result plus is equals to a hash, because I don't have anything in my deq. Else result plus is equals to deq dot back. And after that I'll be returning my result. Let's check this out. If the trivial case correctness successful, let's check the hard ones. Oh, nice. Oh, so there was nothing to do with repeated, because it was starting from start. Great. So I think this was also a good DQ question, and this was the first time I was solving this question, so it's really good that I solved it for the first time and solved it at once. Nice. I took a time of 17 minutes. It's still more. I need to reduce the time. Maybe in future I'll try to reduce it more. Perfect. So I solved 2 stack questions, 1 DQ question. I'll keep this also in my uh, list. So I'll provide all these questions in my description, so you also guys can try it later if you want. That will be a great help for all of you. Okay, there is a question of generating all the parentheses. Maybe we can go with recursion in this also, or I'll think over it. I think this will not be that much hard question. I don't think. Okay, perfect. So we solved some stacks, some queue question, some binary search question. Let's jump to bit two pointers. Let's largest rectangle in histogram. Let's have something as I'll sort this with topic wise. This is stack question bold and I'll do underline, and this is a Q question bold and underline. In that case, we'll get to know a binary search question. Let me add those also. Which question did I solve today? This is a rotated sorted array. Binary search. So this is my binary search question. This is my stack question. This is my queue question. We also solved few more. In stack and queue, we solved this evaluate expression. I'll add this in my stack question. Okay, maybe if I'm missing something, you guys can tell me. I'll add that also. Now let's jump to some two pointer question. Two pointer, then we can go for some backtracking, hashing, heap, map, tree. Oh, there's lots of questions that we can solve. Let's go. There are some trick questions also. Great. In place update. Great. Some multiple arrays question. Okay, we have elapsed our time. Maybe I'll go with container with most water. Array 3 pointers, max continuous series of ones. This can also we can go for maybe these two. Let's pick these two after a break, short break, and in the section of sorted arrays we can pick this also. Let's try it. So these two and this three questions we'll be solving after a 10-minute break. We'll be solving these three questions. Okay, let's have a break of 10 minutes. See you after break. So I'm back. Okay, let's solve some more two pointer questions. So we are going for two pointers, right? So we have two pointers here. Let's add this in our list. Two pointers. So for tricks question, first question of two pointers. Oh, this is three pointer. Why it isn't two pointer then? Okay, so you are given three arrays A, B and C. All three arrays are sorted. Okay, I have given three arrays, array A, array B and array C. All three are sorted. It's given. Find index I, J, K such that maximum value of absolute value of A of I minus B of J, absolute value of B of J minus C of K, absolute value of C of K minus A of I is minimized. Return the maximum max. So we have to minimize the maximum. The question says minimize the maximum. Now return the minimum max is the absolute value of x and is implemented in the following manner. What is this? Absolute of x is the absolute value of x and is okay. This is just saying that absolute value of whether it is negative or positive, it will give me always positive return answer. Oh, that's fine. Oh, we have only one example. Great. Okay, let's try figure if we get some intuition with on this. So we have 1, we have 4, we have 10, we have 2, we have 15, we have 20, we have 10 and we have 12. So these are the array. I need to minimize the maximum, correct? With 10 from A, I'm taking 10 from A, okay, 15 from B, we are taking 15 from B and 10 from C. So see, there is one thing that we were very much particular about. It said that three of them are sorted. We need to find a way to utilize this three sorted array. Fully utilize this arrays because they are in sorted order. We need to figure it out some way how we can do it. So we need to minimize the maximum. Minimize the maximum. Minimizing the maximum means what? We need to find three values. Maybe these three values should be very much closer to each other. If they'll be very much close to each other, we can say that okay, if I do a subtraction, even a subtraction between these, so suppose these are three, these three we took, so 10 minus 15, so we are taking the absolute value of this, Now that was a maximum. We were taking the maximum, right? So 10 minus 15 is 15 minus 10, and the third is 10 minus 10. So we are taking the maximum out of these. So this will return give me 5, this will return give me 5, and this will return give me 0. So see, if I'll have a closer difference between the values, I'll get the minimum answer over here. If you are getting what I'm saying, if I suppose that this value is 12 and this value is also 12, what we will get a value 3 over here. Maybe let's just take this as 13 and this is 12. Now see, these two values are very much close to each other. These two values are lesser close but close. These two values are exact same. So this will always in return give me a value 0. This will give me a value 2. This will give me a value 3. So I need to find the maximum out of these three, which is 3, which will in return give me an answer of 3. So what we can observe from here is the closer the value are, the possibility will increase of us getting a value very less, minimizing the value. This is what we had to do. So this is how we are going to approach this question. So how now we need to figure it out. We figured what we have to do exactly. We have to close the values as much as possible. Correct. Now we need to figure it out how to move the 3 pointers. We'll have the 3 pointers over here. One pointer, maybe I'll change the color. One pointer at A of 0, one pointer at B of 0, one pointer of C of 0. Now we need to figure how we move the pointer, which pointer should we move so that we can get something from here. Okay, so now let's suppose this is my A pointer, this is my B pointer, this is my C pointer. Now we can see 1 minus 2 comma 2 minus 10 comma 1 minus 10, right? At first we'll have these three values. I'll find maximum of these three. This will give me 1, this will give me 8, this will give me 9. So the maximum is 9. Now I know I need to minimize this. I need to minimize this. So we figured out which value should we minimize. So we need to minimize this 9. How we will minimize? We'll see whosoever came as the maximum value out of these three, which value was minimum. I'll move that pointer one more forward. So if suppose in these out of two, this is this and this, which one is minimum? This is one is the minimum. One is a pointer A. This is the pointer C. This is a pointer A. This is a pointer B. This is a pointer B, and this is a pointer C. Correct. So this one came maximum. This is the minimum. We need to increase this. So we'll move the pointer from here to here. Now we'll do the same process again. 4 minus 2, 2 minus 10, and 4 minus 10, 4 minus 10. Now this time, which one is the maximum? 4 minus 2 gives me 2. 2 minus 10 gave me 8. 4 minus 10 gave me 6. The maximum is this. So in this is my B and this is my C. Which one is smaller? B is smaller. I'll move B pointer further. I'll move my B pointer to 15. Now again the same process goes. 4 minus 15. 15 minus 10. And 4 minus 10. 4 minus 15, which gives me 11. Sorry. It gives me 11. 15 minus 10 gave me 5. 4 minus 10 gave me 6. This is the maximum. Which one is the minimum? I'll move my pointer. I think we are getting the intuition how we are moving the pointers. So till now the minimum value that we got is 8. So we'll keep a result which will tell me 8 is the minimum value out of all the maximum that we got. Now we find again the maximum. We have 10 minus 15. We have 15 minus 10. And we have 10 minus 10. This gave me 5. This gave me 5 and this gave me 0. This 5. There are 2 5. So we know that the pointers, we can increase any of the pointer. The values will not create any problem. So these two values are same. So my result will also be updated with 5. Why? Because we need to find the minimize the maximums. So 5 5 5 gives me 5. We'll move the pointer. Which one is the smaller? Let's take this one. 10 is smaller. 10 is A. Remove the pointer. It went out of bound. If it went out of bound, we can't consider this. Means any of the pointers goes out of bound, we'll stop it there only. Great. I think we got the intuition. Let's try and solve this. We got a pointer which will be pointing 0. We got a B pointer 0. We got a C pointer 0. Now this while loop will move while A is lesser than A dot size and B is lesser than B dot size and C is lesser than C dot size. I'll find a result which will be int max. Now I need to keep in my result minimum of result comma maximum of these three values. So A of A minus B of B comma uh, b of b minus c of c. Now a of a minus c of c. C. So we'll get in my result whatever the minimum value that we will have. Now what I need to do, I need to check which one was the minimum. How? Also I have to make absolute, absolute, absolute and absolute. So this will store it in my result. Now we can make some value, maybe val1, which is I'll cut from here, I'll paste it. Absolute value of this, val2, which will be absolute value of this, val3, which will also be an absolute value of this. Perfect. Now I'll make val1, val2, val3. Now this is a question which is we need to find the maximum out of these three values. Either we can go with a if condition or else condition, or we can take a maxi variable which will also keep this maxi. Now if my maxi matches to val1, that means the maximum value came from val1. Else if maxi matches with val2, that means my maximum value came from val2. Else my maximum value came from val3. Now I need to find the minimum value. Okay, so val1 int now if val1, that means a and b. So if a of a is lesser than b of b, to increase my a pointer, else increase my b pointer. The same thing will go over here also. If b of b is lesser than my c of c, then increase the b pointer because this value is lower, else increase my c pointer. And in the third case, if a of a is lesser than c of c, so I'll increase my a pointer, else I'll increase my c pointer. At last I'll return my result. Okay, so trivial case passed. Let's try and submit this and see whether we are passing all the cases or not. Okay, nice. So this was also a good question. We found some great intuition in this question. So this was also nice. How we approached the question was also good. See, you in this question you can see that how we handled small things, and we kept adding those small things, and we made an answer. Like we first found, like, okay, we need to minimize the maximum value. Okay, that is one of the case. Now the second thing which we found is which pointer to increase. So the maximum value, whosoever will have the maximum value, I know that the pointer in that case will be increased. Now in third thing what we found is exactly which pointer to increase in that maximum value. We found a maximum value. Now which pointer to increase in, there will be a two pointers. So pointer which has the minimum value will increase the pointer with, will increase that pointer. So this is the way we solve this question. It's nice. So I'll add this in my question list of two pointers. Great. We solved this question. We solved this question also. I added this in my list. First non-repeating character. Okay. This question is solved. Let's try and solve the another question. So after this, we'll take a 1 hour break for lunch, and then we can continue after that. So let's solve container with most water. So we are given a non-negative integers a1, a2, and an till an, which where each represents a point at coordinate I and ai. Okay, that and vertical lines are drawn such that the two endpoints of the line I is at I and ai and I and 0. Okay, find two lines which together with axis form a container such that container contains most water. The program should return an integer which corresponds to the maximum area of water that can be contained. Yes, we know maximum area instead. Yes, we know maximum area instead of maximum volume sounds weird, but this is 2D plane. We are working with a for simplicity. That's fine. This question also has a 3D question. This also has a 3D approach. Maybe we can try that question also, which was a container with most water and something with most water also only. So we'll try that question also. You may not slant the container. Okay. I'll not change the containers. Fine. So what we are given? We are given containers, multiple containers. Maybe let's consider this as one. maybe this is 5, this is 4, and this is 3. Okay, now it is saying that 5 and 3 are distance 2 apart. So the size of base is 2. Height of container is equals to minimum of 5 comma 3, which is equals to 3. So the area is 3 into 2, that is 6. How are we doing this? I do have this question on my lead code where we have a better explanation, maybe with figure, so that I can understand with in a better way. Container with most water, let's search it. If I have okay, so this is the figure what actually was, not this. So we have a container with height of this, something like this. Fine, I'll not draw here, I'll just try over here. This is 1, this is 8, 6, 2, 5, 4, 8, 3, and 7. So the maximum that we have is the height is 7, and this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So from 1 to 8, 8 minus 1, sorry, 8 minus 1, that is 7. So total is this 1, 2, 3, 4, 5, 6, 7. Total is 7, means j minus I will give me the total width, and the height is 7. So 7 minus 7 into 7, that gives me 49. 49 is my answer over here. Correct. Okay, then fine, we can what we can do over here, we have 2 pointers. We have this 8, we have this 7. We have this left, we have this right. Now we can only adjust water over here with the level of this, the minimum whosoever has, and 7 minus 0, 8 sorry, 8 minus 0 will be 8. 8 into 1, that is 8. Now whosoever is the minimum, I'll move that pointer. So this pointer is minimum, I'll move my left pointer here. The minimum into the distance. Okay, so I think we'll be able to solve this question also. So we will keep a low pointer. Let's start at 0, a high pointer which will start at height dot size minus 1, while low is lesser than high, because if they are at the same point, that doesn't mean anything. So we are also keeping a result currently will be initialized with 0. I need to find the maximum, so maximum of result or minimum of this HEIGST height of low comma HEIGST height of high. Whosoever is the minimum in these will be multiplied with the distance between high minus low. Now if low is lesser than high, then I'll move my low plus plus, else I'll move my high pointer plus plus. I'll return my result. Okay, perfect. This is accepted. Let's submit this and see whether we are getting any wrong answer. Okay. Oh, sorry, not I plus plus, I minus minus. My bad. Still. Okay. Is it? Do we have to go to? Okay, there is a bar of 17. So directly 18 and 17. Minimum is 17. This should give me 17. 2, 3, 4, 5, 18, 17 and 6. So I have my left pointer here, I have my right pointer here. The minimum 0, 1, 2, 3, 4, 5 and 6. So the minimum is 6 minus 0, that is 6, high minus low, right? 6 multiplied by 2, that is 12. Now left is smaller. I moved my left pointer. 5 into 3, 15. So 15 will be in my answer. I'll move my left pointer again. 4 4 into 6 minus 2, that is 4. 4 4 just 16. So 16 is one of my possible answer. I'll move my low pointer again. 6 minus 3, that is 3. 3 into 5, 15. Still not. Still 5 is. I'll move my pointer, low pointer again over here. Now this will be 6. 6 minus 4, that is 2. 6 into 2, that is 12. Now this time, oh, oh my god, what mistake I did is it should be height of low, height of high. Perfect, accepted. Now let's just make copy this and paste it in container with most water. Critical case passed. Hard case success. Nice. So this was also a good 2-pointer question, I would say. So let me add this in 2 pointers. It's a good 2-pointer question. Nice. We solved 2-pointer question. Let's solve one more 2-pointer question. Which one I was thinking of? Maybe this one, intersection of sorted arrays. Let's try with this one. Let's see if I'll be able to solve it in 13 minutes or not. At least if I'll be able to create a logic or not. Okay, find the intersection of two sorted arrays, or in other words, okay, I need to find the intersection of two sorted arrays. Given two sorted arrays, find the all element which occur in both arrays. The purpose of this problem, as also conveyed by the simple cases, assume that element that appear more than once in both the arrays should be included multiple times in the final output. So what exactly it is saying? You have 1 2 3 3 4 5 6. This is my A pointer, this is my B pointer. 3 3 3 3 and 5. What I need to do, what I need to find over here, find all the elements which occur in both arrays. Expansion 3 3 5 occurs in both the arrays A and B. 3 3 5 occurs in both the arrays. Second output only 3. Okay, this we can do with a hash map. It's very simple. You can keep a map, you can keep a value, and it maybe not even its count. Okay, its count. Yeah, its count will also keep, and we'll store all the values of this in our map, and then we can store all the check whether 3 is present or not. If 3 is present, I'll reduce the value. If 3 is present, I'll reduce the value. But this is given a sorted array. We can use 2-pointer approach also. Let's try to have some intuition over here. How can we do it? We have a left pointer here, maybe pointer A here, pointer B here. Now they are not same. Which one is smaller? I'll move this pointer. Not same, which one is smaller? I'll move this pointer. They're same. So we'll add a one of the possible answer will be 3. One of the possible answer. Now in this case, I'll move both the pointers. I'll move B also. I'll move A also. Now 3 matched again. 3 again will be my answer. I'll move A also. I'll move B also. Now they did not match. Who is smaller? A is smaller. Move A. They matched. 5 is my answer. I'll move my A pointer also. I'll move my B pointer also. B pointer went beyond. If any one of the pointer goes beyond, it means it's done and dusted. So it will be very simple approach. I think I don't have to do any very much over here. We'll keep a pointer which starts at 0. We'll keep a B pointer which starts at 0. We'll make a for loop. I is equals to 0. No, let's not make a for loop. Let's try with while loop. While a is lesser than a dot size and then b is lesser than b dot size. Okay. In this case, now if a of a is equals to b of b, if they both matched, that means this is one of my possible answer. I'll keep my result. I'll push result or push back maybe a of a. I'll push in my result and I'll increase my a pointer as well as my b pointer. Else I'll check whether a of a is lesser than b of b. If this is the case, I'll increase a pointer, else I'll increase b pointer, and I'll return my result. So this works. Okay, triple case passed. Let's submit and see. Perfect. This was much more easier than, okay, it was actually an easy question also. So let's copy this also and keep in my 2-pointer section. Okay, so this was a good, not very hard, simple question. Now we still have 5 minutes. Can we try some other question also? Sort by color, maybe. See how this pans out. Given an array with an objects colored red, white and blue. Okay, there are three colors. Sort them so that the object of the same color are adjacent with the colors in the order red, white and blue. We'll use three integers 0, 1 and 2 represent red, white and blue respectively. Note using the library sort function is not allowed. Okay, I don't have to use the sort function, I need to. And also I don't have to return anything. This will be updated in place. I just have to replace some values. Okay, let's see how we can do it. We have an array A. We are given 0, 1, 2, 0, 1, 2. This is the value. This is a good question. If you guys want to try this out, you should try this out. This is a very good question. So 0, 1, 2, 0, 1, 2. We got this. Now I need to sort it according to the answer should be 0, 0, 1, 1 and 2. Correct. Now maybe I'll take 3 pointers. One pointer for 0. Let's take this 0. Then for 1 we have 1 pointer and 2 for 2 pointer. 2. These are the 3 pointers which will be at 0 initially. If we would have given the liberty to use another space, then this would have been very much easier question. Now we have to do it in place. So my 0 pointer will point here. My 1 and 2 pointer will point over here only. They all are at the same position. What I will do, I'll pick this. I see that this value is 0. I'll do nothing. I'll have to move my and one should be my iterator which will start at 0. Negative 1, negative 1, negative 1. Iterator at 0. This is the value 0. So my 0 was actually at negative 1. So I'll do nothing. I'll point this 0 to 0 and I'll update this with 0. Now this is value. Now I'll move my iterator to 1. This is a 1. See, the first time we have a 1 has occurred. Maybe we can skip 1. Let's skip 1. Don't do anything if we have 1. 1 will be sorted eventually. We have 2. We found 2. Now let's keep a 2 pointer at the last. Maybe I'll keep this 0, 1, 2, 3, 4, 5. My 2 pointer is here. My 0 pointer is here. My 2 pointer is here. Perfect. My 2 pointer is 0, 1, 2, 3, 4, 5. 5 at index 5. Let's solve this question and then we can go for a Lunch break. IT as 0 will replace the value with the 0 pointer and move my 0 pointer one step forward. So now my 0 pointer will point here. I saw this in my iterator went to 1. I saw it's 1. I'll move. I saw it's 2. I'll replace this with this pointer, this value. I'll exchange and decrease my 2 pointer here, and will not increase my iterator, because there might be possible that this value will also be 2. So this we found again 2. So I'll replace it with here. So this will be 1 and this will be 2. Now my 2 will be here. Now this is the 1 value. My iterator 1, I'll skip 1. 0, I'll replace with this. I'll replace 0 here and 1 here. Now this is sorted. Perfect. Let's code this out. Maybe I'll keep a integer 1 pointer, not 1. I'll keep a 0 pointer at 0 index, and we'll keep a 2 pointer at a dot size -1. Now while it is lesser than 2 pointer, it will be 0. While iterator is lesser than 2 pointer, I'll just move, else I'll break. Now if a of it, if array of it, let's take it nums. If nums of it is equals to 0, if this is a 0, that means I'll replace this value with the 0. So int val is equals to nums of 0, and nums of 0 is equals to nums of it, and nums of it is equals to val. Either we could have used a swap function. My iterator will increase in else if nums of it is equals to 2. If this is the case, I'll do the same thing. Nums of 2, nums of 2, nums of it is nums of val. But in this case, I'll not increase my pointer. In this case, I'll not increase my pointer. I'll just continue, else I'll increase my pointer. I don't have to return anything. Let's run this and see. Oh, okay. I forgot. It'll go TLE0. I need to increase my 0 pointer, and also I need to decrease my 2 pointer. A was not declared. Triple case part. Let's see if Okay, I still have a 0 over here. Perfect. So this is one of the good question. I say sort by color. I would recommend to solve this question. This will give you a great idea how how to solve, how to approach these types of questions. So it was great solving these few two pointers question. Now I think after my lunch break we'll be going with some backtracking, hashing, heap map tree, DP and greedy. Okay, we have a lot more to go. I think we won't be able to reach the lead code questions. Is it so? I don't know. Let's see if we'll be able to reach random lead code questions or not after solving all these questions. So next we'll be starting with these questions. Okay, so till now it was a great learning. Let's take a longer break. Maybe I'll increase it a little to 50 minutes. And we'll see you after lunch break. Hello everyone, I'm back. Let's 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 start with some more coding questions. Okay, so okay, so which question should we start first? We've already solved a few of the two-pointer questions. Those were nice two-pointer questions. So we'll start with solving few more normal questions. Maybe we'll go with backtracking, hashing, heaps, tree data structure, DP, greedy, and then graph. So let's start with backtracking. I don't know why it's light color. Let's start. Okay, those were theory. Now we have some game solving, which is NK, queen, subset, all possible combinations. Okay, let's try with some combination sum 2. All possible combinations, subset combination sum 2, combinations, and subset. Let me turn off the live chat. Okay, let's pick some questions. Maybe combination sum 2, subsets 2. We'll try these questions. Combination sum 2, subset 2. Maybe even we can try permutations also. It's a 350 points. Maybe gray code also. Okay, one by one. Let's go one by one. Combination 2, then subset 2. Given a collection of candidate numbers C and a target number T, find all unique combinations in C with the candidate numbers sums to 2. So these are a few questions that I am going to solve. These are questions really good recursive backtracking questions. Yeah. And it might be possible that I'll be able to solve this question, or even if I'll not be able to solve the question. So we need to see the solution if I'm not able to solve this question, but still I'll try my best to solve the question and give you intuition how those backtracking and everything works. So let's start. So it's saying that given a collection of candidate numbers C and a target number T, find all unique combinations C where the candidate number sums to T. Okay, let's see. It's saying that I need to find all the possible combination that sums up to this target. Means as we can see, one, if we pick 1, if we pick 7, it'll sum up to target 8. If we pick 1, then 2, then 5, that'll sum up to target to 8. That'll sum up to 8. this will sum up to 8, this will sum up to 8. So all these are summing up to 8, and these are not in sequence. You might be think you might think that okay, we'll pick some sequence and those sequence sum will be equal to target, but no, it's not the case with that. If that would have been the case, we would have used some sliding window approach, but this is not that case, so we'll go with recursive approach. So we know we picked 1, and we are not continuously picking 2, we are picking 7. So these two picked will be formed 8, and we are picking 1 2 and then 5. This is making my one of my answer, then 2 6, then 1 1 6. So how to approach these types of questions? So we can see, I'll show you with an example. Let's take this example as 10 1 2 7 6 1 and 5, correct, and my target is 8. Let's try this. I have 1, this is my target. So maybe it might be possible that I'll pick this I'll pick this and keep this in my solution. Okay, I'll pick this as a solution, as a part of solution, not as a solution, but I'll pick this, I'll say pick this as a part of solution, or not pick this. Simple. Either we can pick this, either we can not pick this. These are the two things that we can do in this, right? Same thing for this. Either we can pick, either we can not pick. So suppose if we are picking this as in my answer, we need to make target as 8. You can see that 10 is going beyond 8, so we won't be picking this as in my answer, because this will not form my answer. So we'll not pick this one. Okay, we are not picking this, we are going to 1. Now if we are will again have two choice, whether to pick this or to not pick this. Okay, if we are picking this, then we go to another index. If we are picking this, we know that this will form this will be in our answer, because our target is 8, and my right now my sum is 1 only, because we picked only 1. So now my target will be updated to 7. Now I need to make only 7. I don't have to make a 8 or 9 or 10 anything else. We need to make 7 because we have already picked 1. Now we go to the next index. You see, we'll again have two options, whether to pick this, whether to not pick this. If we are picking this, we'll add this in my answer. 2 1 plus 2, that'll be 3. I'll reduce 2 from this. Still we have some target to achieve. We haven't completed it. So I have picked this, I have 1, I have picked 2, and I'll go and pick 7. I'll try to pick 7. If I pick 7, you can see 5 minus 7 will give me a value which is negative. That will not be part of my answer, that will not create my answer. So I'll not pick 7. I will again have choice to not pick and pick, but this will not create my answer, so I'll not pick this. I'll go jump again to next index. Now again next index is 6. I need to create 5 only, but 6 is greater than 5, so we won't be picking this again. We'll go 1 again. If I see 1 can be picked. 1 can be one of the possible answer that I can pick. So I can add this in my answer, and I'll reduce 1 from here, and I'll form 4. I need more 4 to make it to the target. So I'll try and jump to the next index. I'll pick 5. Yes, Saurav Shekhar, shout out to you. So I'll again pick 5. Now I can see 4 minus 5 will again give me -1, which is not possible. So we won't be picking this. Now I am streaming. Now I'm not on break. Sorry. So we won't be picking this, but we still haven't created our answer. We'll fall back because there is no index which I can go beyond. So we'll fall back. Let me color it with something other. We are falling back to 1. Now we had an option to pick this and not pick this. Earlier I picked this. Now I'll not pick this. I'll go back again. I'll jump. I'll do a recursive call again, and this time I'll not pick this. If I'm not picking this, this 1 will be reduced, and this will also be, my target will be reduced to 5 because I'm not picking this. I jump back to 5 again. Now if I have a chance to pick this and not pick this, if I'll pick this, 5 minus 5, which will give me 0. So I can say that one possible answer is 1, 2 and 5. This is one of my possible answer. Now I'll add it in my resultant list. 1, 2 and 5. This is my one of the answer. Now I'll again fall back to 1. I've already picked this and not picked this, so again I'll fall back to 6. So this will be removed, this will be removed. We'll go back to again. So earlier we did not pick this. We already tried picking this, but it was not forming answer, so I did not pick this. So both were completed for this. I'll fall back to again this 7. Also we earlier picked this, but it was not completing my answer, so we did not pick this. So we both were completed. We'll fall back to again to 2. So 2. Now we can pick this, we cannot pick this. So if earlier we picked this, so then we were creating some answer. Now we will not pick this, and we will again do a recursive call. So if we are not picking this, my only sum is 1 because we picked only 1, and right now we are not picking this, so my answer that will be left to form is 7. Now I'll go to 7. I can see that 7 minus 7 will give me 0, so this is one of the possible answers. So my answer set will contain 1, 7. So this is the way, this is the approach of picking and not picking and forming our answers. So this way we can solve this question. Let's try and code this one and see how can we do it. Okay, I'll solve this only. I think backtracking questions are not very much hard. It's more of a brute force. I'll try only solving this question, and then we'll jump to another topic maybe. Let's see. I have nums. I have target. I needed to return vector int resultant. This will contain my result. I'll be returning my result, and I need a vector int answer. Then I'll call this solve method. I'll pass this nums. I'll pass this target and pass an index which will start from 0. This will be returning nothing. I will also pass answer. Now maybe answer and result both. So we have nums, we have target, we have nums, we have target, we have index, then we have answer, and then we have result. Now what I will do, I'll have two options, whether to pick or whether to not pick. These are the two options that are available to us. So what I will do, the base case will be if my index goes beyond. Base case will be one possible if my index is beyond or even equals to nums dot size, I'll return. Or if my target becomes equals to 0, I'll add it in my result dot push back answer. So suppose I'm picking this in my answer, so I need to check whether if I'm picking this will be a valid answer formation of answer or not. So if I'm picking this answer, I need to check with my target, if target minus nums of idx is greater than 0 or even equals to 0, this can then nums of idx can be one of my answer. So what we will do, we'll call a solve again, which will contain nums. Now target will be now the leftover will be nums of idx. I have my answer. I'll be pushing answer dot push back. Answer dot push back nums of ideas. So I'll push this in my answer, and after returning I'll also pop back my answer. I'll pass answer, I'll pass result. If I'm picking this if I'm not picking, I'll only have to move to the next index. Also target reduced, I need to move to the next index, idx plus 1. I'll have if I'm not picking, then I'll go directly with the target will be as it is because I'm not picking this index. I'll just increase my index and the answer will be as it is and my result will be as it is. Let's try and run this and see if my recursion is throwing some error. Oh, sorry. This result is my vector int. Triple cases failed. Okay, so the expected is, and my function returned, okay, unsorted 10 6 11 1, and again 10 6 11 1, 1 6 10 11 1 8 8 11. uh, 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 do we need to why 1 11 16 11 1 16, why 10 6 11 1 and 10 6 11 1 is coming twice for this example. 10 6 11 1, there is no I reduced my target over here, index increased, answer result, answer dot pop back. uh, 1 8 8 11, this should have returned. Okay, why 1 8 8 11? Okay, 8 11 1 8. So I'm picking this and not picking this. Should have returned from here also. Ten six 11 1 11 1 6, and 1 8 8 11 is not being returned. 1 8 8 11 1 8 should have. Why it didn't? Maybe I'll do it over here. That even doesn't matter. I am pushing back and then I'm popping it back. My nums will be as it is, my target will be as it is, my index will move one step forward, my answer will be as it is, my resultant will be as it is. Correct. Even if I do not do this, I'll directly call these methods push back and pop back, and here I can return one more, add one more condition if okay. Now I know why it was not coming. Okay, got it. I will have to put it below. And also return these small mistakes. I need to keep it in my mind. Now the answer is coming, but it needs in a sorted way. The solution set must not contain all the numbers will be positive, must be in non-decreasing order. Maybe what I'll do, I'll sort this sort nums dot begin nums dot end. Why we are getting these many solutions? 1518 repeated. Okay. Should not contain any duplicate. Okay, how to handle the duplicate? Either we can do is we can handle it over in the nums only directly, or we can do something else. See, 37815 is occurring twice because there must be any one of the value in this that will be that is 2 times. Okay, see 3 7 8 15. See, 15 is twice. So I picked this. I need to know. Even I can solve this solution using a for loop that will help me in solving the duplicate problem. Okay, let's handle it. So what I will do, I'll start with idx. I is equals to idx. I is lesser than nums dot size plus I. Now inside of this I'll have this condition: if target minus nums of idx is greater than equals to 0, if this is greater than equals to commented. Now this is greater than 0, and one more thing that if I is not equals to idx, if I is not equals to idx means they both are not same, and uh, nums of I is equals to nums of idx. In this case I'll continue this for loop. If I is not equals to, and nums of I is equals to nums of I minus 1. Why this time more repeated question answers are coming? Hmm. Combination sum. How to handle the duplicate? This, this can be handled very easily. I sorted, I created an answer, solve target 0. Here it goes. If j is greater than I and candidate of j is equals to candidates of j minus 1, that is what I did. If I know nums of I is equals to nums of I minus 1, I'll continue. If sum plus candidate is lesser than, just I'll add it in my sum. I'll push back in my answer. I'll call the solve. I'll reduce and I'll pop back. Okay. So we are simply not considering the negative part. Oh, okay. Should have made I plus 1. 188 11 1 11 16. answer dot pushback nums of I, target dot minus nums of I. Hmm. So this is the condition where I'm filtering out the not pick things. Nice. Okay, so this was a good question. I say I forgot many of the things in this. So I'll add this. Add recursion. This is some recursion question. Okay, nice. Maybe I'll try with this. I'll try this one also. Given a collection of integers that might contain duplicate as return all possible subsets. Element in the subset must be in non-decreasing order. The solution must not contain duplicate subset. The subset must be sorted lexicographically. What I will do, I'll initially sort this. Okay, let's make this nums. Initially, it's very similar to the question which we did earlier before this. Okay, sorted. I'll call my solve function, which will be giving all the subset present. I need to return a vector result. I'll pass this norms. I'll pass an index, and I'll also pass an answer. This will contain the possible answers, and this will contain the result. Now let's solve this. This will not return anything. I have a vector int ampersand nums int idx. This will be my idx. Vector int ampersand answer and vector of vector int ampersand result. And now if my idx is greater than or equals to nums dot size, in this case I'll push it in my answer. So result dot push back answer and return. So again int I is equals to idx, I is lesser than plus I. Now what I need to do, we need to somehow pick and not pick. This is the thing that we have to do. But if we are picking, if the case will be same, if idx phi is not equals to idx and then nums of I is equals to nums of I minus 1. If this is the case, then I'll continue. Else what I'll do an answer dot pushback nums of I. I'll call this solve method. Say I instead of I, it'll go I plus 1. Answer will remain as it is and result. Now answer dot pop back. This will pop. Run, and if I see any trivial cases, the function returned the following. So maybe I'll just directly push an empty array result dot pushback answer. This is an empty. This will create repeating. The expected return value is empty and 9, and my function returned 9 and empty. Okay. Should I do something like this? Yeah, see, this will give me a repeated. Now I need to stop this repetition. Can I even call this inside? Do a call. Five, four, four, five. Okay, these are some small recursive but tricky one. Subject to how I handle those duplicate. No, I need a recursive answer. Maybe ah, I created a result, vector it and contains if start is greater than num start size return result dot pushback. Okay, I created an ordered map. If m dot find nums of I is not equals to m dot and continue. I think there must be some better approach. I don't want to use bit masking. Ah, backtracking. If the element has duplicates, which element among the for the better understanding, we have an empty, we add one. If it is not equals to continue, push back this and pop back. we are just calling and creating our answers. We are just calling directly. Now why? Even we don't want that also. That is not an issue. Total subset dot pushback current subset. I sorted it. I haven't done the same thing. I did the same thing. Why? I also did the same thing. Result not pushback answer it. Answer dot pushback nums of I. Solve will be called as nums I will plus 1 answer and result. Okay. Why this happened is because of this. Okay, and I'm forgetting these small base cases handling. I'm forgetting this base case handling. Should remember. Took a lot of time for me to solve this. There are two ways a recursion is being called. If we are solving a dynamic programming, we were creating answers. Okay, so I finally figured out the recursion has two major part. If it is a brute force recursion, I can track it down while following the recursion tree. What it showed over here, if I can show you. So this is what it showed. If it is an empty, initially I have an empty array. I'll push this in my answer. I'll create one and I'll push it in my answer. I'll create and push this in my answer. Now this is why this will not be in my answer, because one is index and second index both have the same value. So for that we are handling it over here. If the previous index value is same, we are continuing. Nice. So I can say that this is a recursive question and was majorly I can track down with top down approach only, because if it would have been a dynamic approach, I would have to go backtracking and then solving it. Okay, after this maybe I'll try to solve one more question. Maybe I'll go with palindrome partitioning after this, and then we'll go to some other topic. Okay, let's have a 10-minute break and then I'll see you after break. Back. Let's try and solve more good questions. Maybe if Krish is there, let's talk to him, see what he is up to. Hey, hi Krish, are you there? Hello, I hear you. So, how many questions have we solved till now? 55? Really? Nice. We only solved, only solved 10 questions. Very, very bind. Okay, I think you are not very much audible properly. We can go your voice. There is noise, a lot of noise in your voice. Now it seems you have been studying a lot today, so it's great. Let's do few more hours and then we are good to go. Okay, all the best. Okay, so what I was trying to solve, palindrome partitioning. Solve this question and see what exactly are we up to. Given a string as, okay, we have been given a string as partition as such that every string of the partition is a palindrome. Return all possible palindrome partitioning of S. For example, given as AAB, A is a palindrome, A is a, like, individually each and every string is a palindrome, character is a palindrome, and then AA is a palindrome. That's it. Entry of I will come before entry of J. So I need to partition it in such a way that every string or every substring, I would say, is a palindrome. Now what is the condition for palindrome? So the condition for palindrome is very simple. The uh, if we divide it in the middle half, we can say that left half is equals to right half from backward something. This half is equals to this half. For example, A B C D and C B A. So you can see this is a palindrome from here if I study this it'll be same, and if I hear from here I'll study it'll be same. So this is a palindrome. Now how we are getting to know that this is a palindrome? And also A, B individually is a palindrome, right? So in this case what I will check, how we are handling the palindrome part. Okay, solve. I need a vector of vector, so I need a string. I need a vector of string which will form my answer. I need a vector of string for storing the answer in my resultant. Now solve contains a string s, maybe I'll take s. Start with 0th index. I have my answer, I have my result. This will be a void solve will contain a string s, an index idx, vector of string s, answer, vector of string result, and I'll be returning result. So I'll only push my answer into my resultant vector if my ID index goes beyond or equals to s dot size, then I'll push back answer and then I'll return. I'll have a for loop I which will start from idx. I is lesser than maybe s dot size plus plus I. Now what I need to do, I need create a substring and check whether it is a palindrome or not, and then push it in my answer set. But there will also be one palindrome checking method. So what we will do is we will create a string str which will be s of will create this string outside. Initially it will have nothing. Now str plus is equals to s of I. Now if check of str is equal to true, means this is a palindrome. Check or palin. If this is a palindrome and it's a true, I'll push it in my answer dot push back str. I'll call my solve with s. idx will go I plus 1. Answer will be answer and resultant will be my result, and after falling back I'll just pop back. Now I need to create a check method which will return a boolean palin. Maybe is palin making more sense. No, this palin will contain only a string. Now this string I need to check. Let me pass this string, and I'll have a low pointer will start from 0. I have a high pointer will start low is lesser than equals to high. Now if s of low is not equals to s of high, I'll return false, else my low will increase and my high will reduce. I'll be returning true. Okay, let's see if it is giving me any correct answer or okay. Trivial key is corrected. Let's submit it and see whether everything is working. Easy passed, hard passed. Perfect. So now I'm able to solve recursion questions also. So it's good. So maybe I'll copy this one also, and it's perfect. And now I'll move to some other topic. And we'll try and solve some more questions. So backtracking is done. I'll try with some hashing questions. Let's try this. Log hash substring without repeat. Subarray with b odd. Diff defecto. First repeating element. Okay, this has a point of 350 and still it's an easy question. Okay. Solve at least once. Okay, so the question says, given a string A, find the length of the longest substring without repeating characters. Note, users are expected to solve in O of n time complexity. Okay, given a string A, I have been given a string A, find the length of the longest substring without repeating characters. Means the characters should not be repeated. It's a good question. A B C A B C B B. I only need to find the length. Okay. So I see A B C A B C B B. What I can do, I can keep a hash map. I'll keep a left pointer. I'll keep a right pointer. I'll insert this in my hash map with a value of 1. I'll move my right pointer B as 1. I'll move my right pointer C as 1. Now I saw a value A. My right pointer is here. A came twice. Okay, I'll directly solve this. This is not going to be a hard one. Int I is equals to 0. Right is also equals to 0. I'll keep an unordered map. Map will contain character with integer. I'll name it as map. I'll keep this as S. I is less than S dot. Now M of S of I plus plus. Now while M of S of I, M of S of I is greater than 0, sorry, is greater than 1, means its character has occurred twice. M of S of I, sorry, okay, left and right, okay, what I did is, let me change, while my right is lesser than S dot size, M of S of R plus plus, M of S of R greater than M of S of L minus minus, and L plus plus. Result is equals to maximum of result R minus L plus 1. This is the range, and R plus plus return result. I'll also keep a variable result which will be equals to 0. Great. No, shit. Here's my note list. this is actually hashing question, bold underline, bold underline. Okay, substring. So it's done. I think hashing questions are not that difficult. Maybe I'll try and jump to the next question. Actually, I'll be back in 5 minutes. I'm just pausing this timer and I'll be back in 5 minutes. start. Okay, so hashing questions were done. Let me try heaps and maps. I don't know how many. This is a 600-point question. Let's try this. Oh, there is one LRU cache also. Oh, it's a 1000-point question. Great. Distinct number in window. Maybe I'll solve this next. Okay, it's a hard question. Let's let's try and figure it out some how to approach this question. Merge k sorted linked list and return it as one sorted list. So we have been given k sorted linked list 1, 10, 20, 4, 11, 13, 3, 8 and 9. I need to merge it. So it might be possible. I've been given list. Okay, there are list, infinite list. So what I will do, I'll keep a priority queue. Priority queue, which will keep two things. One is value and the node. These are the two things that this priority queue will have. I'll put every node's root in this priority queue. So this will contain 1 with node 1. This will be the value and this is the node. This now 3 will be, because this is a priority queue, this node connects. So if it is 1, I know this is my one of my answer. So I'll place 1. I'll pop this, I'll push the next of this. So next contains 10. So this will be popped and the next of this contains 10, which will go to the bottom. 3 will be pushed and I'll push next of the 3, which is 8. 8 will go over here. 4 will be pushed. 4 will be popped. The next of 4 will be is 11. 8 will be pushed. So this way it will go on. And if the next is null, I'll not push anything. Correct. Let's try and solve this question. Priority queue will contain a pair of int and the second will be pushed node. Vector pair of int comma list node creator this is a priority queue. What I will do is I will vector let it be nums for loop and I is equals to 0, I is lesser than nums dot size pq dot push nums of I will give me the root का value corresponding nums of I. So while not pq dot empty, while priority queue is not empty, I'll have a list node root is equals to new list node list node dummy will be pointing to root. I think there will be some problem in this. I don't know the structure will be declared like this or not. So priority queue is empty. I'll pick pair and list node asterisk of node pair is equals to pq dot top pq dot pop. I'll pop this. I'll create dummy dot next will be node pair dot second and dummy is equals to dummy next and dummy is equals to dummy next will be equals to null. Now this node pairs next value should be inserted. So before detaching or making it to null, I'll just make push pq dot push node pair. Dummy dummy का next is equal to node pair second. Dummy is equal to dummy dot next. Return I knew that this would have this much to create. I'll create a root is equals to west node pass address. How to declare this dummy? I think have I've had something in linked list. I did create this. It's not dummy. Okay, it was direct. Doesn't matter if I pass. Okay. Return. Sorry, node pair dot second val dot second value here dot first. Now this node will be dummies next, and dummy is equals to dummy dot next. It will go to the next. Now we will only push if node dot next is not equals to null. If it is not null, so node dot next का value and triple K is passed. Let's submit and see. Great, nice. So this is not very hard question. This was pretty easy because I knew how to solve this. Okay, so nice, we did it. Now let's solve this one. Distinct number of rows in window. Maybe we'll be solving LRU cache. If I'm just thinking of whether should I solve LRU cache or should I not. I'll add the chat box for now. So distinct numbers in window. Let's try an approach. What is the actual approach for this question? Maybe let's see. We are given an array of n integers a1 to an and an integer b. Return the count of the distinct number in all window of size b. You are given an array of n integers. I have been given an array of n integers, correct, and an integer b, correct. Okay. Return the count of distinct number in all windows of size b. Return the count of distinct numbers in all windows of exactly size b. Finally return an array of size. Okay, good. Let's see. So we have 1 2 1 3 4 3. This is my array. One two 1 3 4 3. I have been given a window of size 3. So this is size 3. The unique numbers are 1 and 2. Now I'll move forward. This is a size 3. So 2 1 3. this contains all three elements, so 3 is my output. Now the next 3 window is 134 still contains all the 3 elements, assuming the next window contains 2 as unique elements. So maybe this will be a sliding window with hash map. We can solve it using sliding window plus hash map. Okay, let's try it out. This will not be hard. Now I'll have a low pointer which will be at 0. I'll have a high pointer which will be at 0. Now for enter I is equals to 0, I is less than nums. Let's suppose B is my window. While I is lesser than nums dot size. While high is lesser than nums dot size, what I will do? Mm, okay. I'll insert this in my map of nums of high plus plus. Now my while will be while my window, while high minus low plus 1 is greater than window m of nums of low minus minus. So now if high minus low plus 1 is equals to window, I need to create a vector int result. This result dot pushback and dot size. There's one thing that I need to handle, high plus plus and return result. There's one thing that now if m of nums of low is equals to 0, m dot erase nums of low. I don't have to keep it in my map. Okay, nice. So now I'm able, now I can solve this also. Distinct numbers in window. Hey, did I copy the last solution? I forgot to add this merge key sorted list. This is heaps and maps. The topic has changed from hashing to heaps and maps. Bold and underline. So LRU cache, maybe we can discuss this LRU cache. I think it's a long solution. Won't be possible to solve everything. Let's try one more question. Magician and chocolates. Looks looks like a nice question. Magician and chocolates. Now given n bags, each bag contains bi chocolates. There is a kid and a magician. In 1 unit of time, kid chooses a random bag I, eats bi chocolates. Then the magician fills the ith bag with floor of bi by 2 chocolates. Find the maximum number of chocolates that kid can eat in a units of time. Return the answer modulo 10 to the power 9 plus. You have been given n bags. Each bag contains bi chocolates. Total n bags, or every bag has bi chocolates. Suppose there are 3 bags. Bag 1, bag 2, bag 3. These 3 bags contains bi chocolates, means b0, maybe 5 chocolates, maybe 6 chocolates, and maybe 10 chocolates. These 3 bags contains these kinds of. There is a kid and a magician. Okay, in 1 unit of time, the kid chooses a random bag I. In 1 unit of time, this kid chooses a random bag I, eats bi chocolates. Okay, random bag and eats all the chocolates. 6 chocolates, it ate 6 chocolates. Then the magician fills the ith bag with floor of bi by 2. 6 by 2 floor is 3. So now the bag is filled with 3 chocolates. And the maximum number of chocolate that kid can eat in a unit of, okay, in this much of time, how many chocolates he can eat. Mhm. First argument is an integer a, second argument is an integer b of size n. Who is giving so many hearts? Thank you. So A is 3 and B is 6 comma 5. It's fine. Don't give me so many hearts, man. What is A? Uh, A units of time. Okay, in A units of time, how many chocolates it can eat? So we have a chocolate bag of 6 unit, a chocolate bag of 5 unit. Let me remove these all. Time. Okay, okay, thank you. You can stop now. Time is 3 unit. So I'll try to grab as large as I can. So 6, if I pick 6, the magician will make it half. So I can eat 6 in first unit and then it will be reduced to half. Now the largest is 5. I can eat 5 plus 5 and the magician will make it half, which will be 2. I can eat 3 again. So in 3 units plus 3. So 14 total we can eat. So we can keep a priority queue, but uh, we need to optimize this. Can we optimize this? Because the time, how much far it can go. 10 to the power 5. हाँ यही रास्ता है तेरा, तूने अब जाना. भाई साहब, आप तो शायर बन गए. Okay, I think this is one of the possible solution. Maybe I'll solve this question after 10 minutes of break, and uh, then we can even think of some optimization if possible. But right now I can't see any optimization. Let's see. Let's just take a 10 minutes of break and then we'll be back. Hello, I'm back. Let's solve. Hmm. So we were on this question. So suppose Hello everyone. I'm sorry, there was some internet issue with in our side, but now it's fine. Now it's fixed. So I was solving questions even when the internet was not there with my mobile data. But now I think I'll be able to solve it. You guys also. I think the chats are also disconnected. No problem. Actually, I was solving some trees question because I stopped the timer and then I was solving. I solved few binary trees question, but magician and chocolate. So now I'll be solving this right view of binary tree. Given a binary tree A of integers, return the array of integers representing the right view of the binary tree. So we need to print the right view of this binary tree. Let me see. So the right view of the binary tree, if we see from right, if we see from this direction, I can see these nodes, this 1, this 3, this 7 and this 8. These are the nodes that I can see if we are watching from right hand side. And this way we we can see 1, 3, 4 and 5. So these are the nodes that I can see if I watch from right. So the second, for the first output will be 1, 3, 7 and 8, and for the second will be 1, 3, 4 and 5. So these will be output. Now how to approach this question, how we can approach this question. Mm, the one way we can approach this question is really, using a BFS approach, breadth first search. So we will push root 1, we'll pop this out, we'll push all these all the root nodes for this 2, 2 and 3. Now we can say that 1 is it in our answer. Now the top 3 is my possible answer. Hmm. So we'll pop this also and we'll push 6 and 7 in my queue. Even keeping in a queue, uh, it's not going to help me. Maybe I can keep it in a vector, or something that. So we'll keep 1 in our vector, we'll iterate this vector, and one of my possible answer is 1. We'll keep all the nodes 2, 3 in my vector, we'll iterate from left we'll keep 4, 5, then 6, then 7. From this the last value will be kept as my answer. So for this last value is 3, for this last value is 7. I'll keep for 4 it's 8. I'll pop this. For 5 there is no left and right, for 6 there is no, 7 there is no, so this is one of this will be 1 in my answer. So this way we can solve this question. Is there anything we can do with Q? Are they, why the test case hard failed getting most of the problem? I created a result array. Recursion. I need to know the level. If root is null, return. If result dot size is equals to level, result dot pushback root का val level 1. So initially the level is 0. If result dot size is equals to level, now we call this left. 1 2 4 8. We have 4 8 3 7 6. So we have a level of 0. My resultant is 0, so we'll push 1. Now level is increased to 1 and we went to right. Level has increased to 1 and we went to right. Now right to ka. Is there some issue with my mic? My internet got disconnected, dude. Right now it's working fine. Where was I? This is my level 1 and I passed my result. Now result is 1 and this is my level 1, so I pushed 3. Now I called again right. This is my level 2. My result still 1. So we pushed 6. Now we fall back, we called left, but my level went beyond, so I don't have to do anything. Left 1, left 2, left, right is nothing, left 3, F3, because we are trying to reach the maximum at the left. So this way we can solve this. Oh, nice. This is also a good question. If this would have been a left view, I would have solved it with left call first. Because this is a right view, I need to call right first. Let's call this vector int result. Right view. I'll pass this root, level and result. Right view, tree node, root, and this is my level, and now if not root, I'll simply return. Now if my level matches with the result dot size, I'll push my root ka val. I'll call RGST right view with root dot root right, level will be increased with 1 more, and the resultant will passed as it is. Now this right view will be passed with root left, level plus 1 and result. This will give me the resultant, and I'll be then returning my result. So yeah, this was also a good question. Let's try zigzag level. Given a boundary, return the zigzag level order traversal of its node, that is from left to right, then right to left. So it will depend on a condition, depend on an order. If we are keeping an order of 1, we'll be pushing the values from left to right. If we're keeping the order as 0, we are pushing from right to left. This will be 3, then 0 to 9, and then 15 to 7. So from 3, the next level that we are going is 20. That is an odd level, so I'll call right first and then my left first. If it is an even, then I'll call left first, and then my right first. So it will be a BFS approach. I think I won't be solving this question because this will be very easy. This is not so much difficult. If you want, I can. If you want, you can comment in the chat. Then I will solve this question. Else, I'll directly jump to the next question. When I can see, is there any DFS approach um, using flag striver solution? Oh my god, everyone is putting a striver solution here. Why? I don't know. This striver solution is how good or how bad. Simple BFS with single queue and without reverse. Easy DFS using map. Okay, I'll go with BFS approach. I don't want to go with DFS approach for this question. There are few good questions like least common ancestors, flattened binary tree to linked list, order of people heights. This is a segment tree question. So these are pre-order, in order, pre-order, post-order traversal, and these all can be used like we can directly traverse, or we need to use a stack for traversing. So maybe I'll try, and I'll not code the solution, because so coding the solution will be very easy, but at least I'll try to figure it out the actual way how to solve. So this is an in order traversal. So let's suppose we have a tree like 5 7 3 2 4 8 9 and 10. This is a tree. I need to do an in order traversal for this. So in order traversal means nothing but the in order traversal will be 3, then it will go to 5, then left, then it will be 9, then it will be 2, fall back to 1, then it will be 4, then 7, then 10, then 8. uh, okay, we're going out of bound. 8. So this will be my in order traversal for this. Now what I will do, I'll keep a stack. Stack will be of tree node type. I'll push all the elements until and unless I reach a null. I'll push all the left until and unless I reach a value which is very low. So I'll push 1, I'll push 5, I'll push 3. Now there is nothing on its left, so I'll pop this 3, will keep it in my answer, will call the right of this, but I can see there is no right, so we'll fall back, we'll pop this 5, we'll put it in my answer, we'll call its right, and then we'll go till left. So we'll call its right to, we called as left, there's no left now, 9, so 9 will be my answer. We call its right, no right is there, fall back, we put 2 is my answer. So this way we can do the in order traversal. In order traversal, fine. Now let's this will not be very tough. So this is in order, this is pre-order. Let's try the pre-order traversal. I'll go with the C. Oh, removed the tree. My God. I'll form again. So the pre-order traversal for this will be 1, 5, 3, 6, 10, 7, 5, 8 and 9. This will be pre-order traversal. So if I keep a stack, what I will do, I saw 1, I'll push it right and then left in my stack. I pushed 1, I'll pop this 1, I'll keep this in my answer, I'll push its right 7, its left 5 in my answer, I'll pop this 5, keep it in my answer, I'll push its right, its left in my answer, I'll pop this 3, I'll keep this in my answer, I'll push its right and left, there's no right and left. Next I'll pop this 6, keep it in my answer, I'll push its right and then left in my answer. I pop this 10, nothing. Now only left is 7. I'll pop this 7, I'll keep it in my answer, I'll push its right and left in my answer. I'll pop this 5, keep it in my answer, I'll push its right and left, nothing. I pop this 8, keep it in my answer, push its right and left in my answer. So 9, I'll pop this 9, keep it in my answer and push its right and left. So this way we can do this using stack. So I'm not going to code this also. This is not very much difficult. I'll just keep this. If you know the logic, most of the time you'll be able to solve the questions. But if you don't know the logic, it'll be a little difficult for you to solve the question. Okay. So the next is in order. Sorry, post order. Pre-order in order done. Post order left. This will be a little not very much complex. What will be the post order traversal for this? It will be 3. It will be 10. It will be 6. Then 5. Then again 5. Then it will be 9. Then it will be 8. Then it will be 7. And then it will be 1. So this is what my answer will be. I have my root in my answer. I'll pop this root. I'll keep its left and right in my stack. I'll pop it. I'll keep it over here. I'll keep its left and right. Maybe 5 and 7. I'll pop this 7. I'll keep it in my answer. I'll put its left and right, that is 5 and 8 in my answer. I'll pop this 8, keep it in my answer in another stack. I'll put its left and right. I'll pop this 9, keep it in my answer. I'll push its left and right. No, 5. I'll pop this 5, keep it in my answer. I'll push its left and right. There's no left and right left. Okay, sorry, this was the 5. Now this 5 is this one. I'll pop this 5, keep it in my answer, push its left and right, that is 3 and 6 in my stack. I'll pop this 6, keep it in my answer. I'll put its left and right, that is 10. I'll pop this 10, keep it in my answer. I'll push its left and right. There's no. I'll pop this 3, keep it in my answer. I'll push its left and right. So my answer will become 3. I'll start popping from top. 3, 10, 6, 5, 9, 8, 7, 1. So this is the actual solution answer using stack. So this is also cool. I'll copy this. I'll not going to code this again. I'll keep it safe using stack. Can't take it manually. Cool, no problem. Okay, let's take a 10 minutes break. I think we have a contest also at 8 p.m. So I'll be taking a break for maybe an hour, and then I'll start to do the contest, solve the contest question, and that'll be that will be my 10 hours hopefully, because this is a almost 9 hour, 1.5 hour will be my contest time, and I'll be good to go. So today what I did is we learned a lot of questions from binary search. We started from binary search. We solved a few stack questions, then one DQ question also, 2-pointer question. We solved 4 of the 2-pointer question. Then we solved 3 recursive question. Then we solved a hashing question also. Then heap and sort, we solved 3 questions. For binary tree we solved lot 1, 2, 3, 4, 5, 6, 7. 7 questions we solved for binary tree. So the total we solved, I guess maybe not very much. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I forgot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So in total we solved today 22 question. Hopefully I might be able to solve 3 questions in contest. So maybe I'll see if I'll be able to solve in the contest or not. But if that will be 25 questions all in all today. So uh, it's quite good amount. I would not say there were mix of easy, medium and hard questions. Tomorrow I think I'll be picking up dynamic programming questions a lot and graph questions a lot, because I haven't practiced graph and dynamic programming questions today. So tomorrow I'll be mostly focused on dynamic programming questions and graph data structures algorithms. So after solving good amount of DP and graph questions, then we can think of doing some other questions, or going with some random questions on lead code or something like that. But today was very fruitful. I think I practiced a lot, um, and also I didn't feel any exhaustion today because of this Pomodoro. It gave me some time to rest every hour, so it's good. It's quite good. Philly will see you tomorrow morning again. I'll be back with my friend because our internet was down. My friend was also disconnected. but finally he is also connected back, and he also solved a lot of questions. So tomorrow we will also be solving more and more questions, so stay tuned for tomorrow. And I would say that be stay with me connected, and we'll be able to solve good amount of questions, and I think we'll be able to prepare quite well for any kind of interview that will be coming up next. So thank you guys, thank you for everything. It was really great solving questions with you all. See ya tomorrow. Bye bye.